Set in a post-apocalyptic United States, ravaged by a fungal infection that turns humans into aggressive creatures, The Last of Us follows the journey of Joel and Ellie. Joel is a hardened survivor, while Ellie is a young girl who may be the key to humanity's survival. With its realistic immersive mechanics, The Last of Us combines stealth, combat, and exploration, allowing players to navigate environments filled with infected creatures and hostile survivors. How did Naughty Dog craft the AI behind the infected? The infected are humans who have been overcome by a fungal infection, corrupting the brain and leaving them disfigured and aggressive. The infection ravages the body, leaving no trace of personality, compassion, or even self-preservation. The infected are driven only by the instincts of the fungus. Survivors have been forced to struggle not only against the infected but also against predatory groups of survivors, also known as the Hunters. The Last of Us introduced 4 types of infected, while Part 2 introduced a 5th. Runners are the most common type. They are recently infected humans that are fast and attack in uncoordinated groups. They can see, but like all infected, have better hearing. Stalkers are similar to runners, but hide in the dark areas and ambush their prey. Flickers are visually disfigured, with masses of fungus distorting their features and leaving them blind. They use echolocation to navigate and locate their prey. Slower than runners, but have a deadly frenzy attack and ignore melee attacks. Fighters are highly disfigured, blind, slow, and heavily armored. They grab and kill anyone within reach, making melee attacks ineffective. They throw growths from their bodies to deal area damage. Camless was introduced in The Last of Us Part 2. They create hazardous zones with their spore emissions, forcing players to keep moving. In the making of the infected, the goal was to make them feel fundamentally different from the hunters. This was done with a modular AI architecture that allows to easily add, remove, or change decision logic. I am going to share with you 3 steps to recreate the infected in your own game, followed by an example implementation. In The Last of Us, all the infected characters share a single C++ class and are differentiated only by the set of skills and the tuning values in their files. The code will refer to a property of the character instead of testing for a specific type, keeping the code general. This gives designers control over character variations. When adding a new type of infected or changing an existing one, there is no need to hunt for all the places in the code that refer to a character's type. Step 1. Create a C++ data asset file. In the C++ file, create an enum for speed. This will be used to drive the movement speed of the infected. Next, create an enum for vision. The infected has limited to no eyesight. This will be used to indicate if the infected character has any visual perception. Lastly, create an enum for rarity. This can be used when spawning infected characters and how often they appear. Add public properties of each enum type to the data asset class. Next, add a public property of the data asset class type created to the NPC character C++ header file. When it comes to senses, all infected rely primarily on hearing to reveal enemies and distractions in their environment. They track how and when they sense each entity and focus on the one most threatening. The Sentry system does not use the actual audio heard in the game, but logical sound events that are generated specifically for this purpose. This gave game designers more control, allowing them to specify which sounds are heard and at what range for each character type. Step 2. In the NPC character C++ header file, ensure that there is a begin play event and a constructor. Add a perception component property. Set up the perception component property in the constructor. Add an update vision function to the C++ header file and implement in the code file. Call the function in the begin play event. This function will use the vision property in the character type property to enable or disable the sight perception of the NPC character. Implement the active perception updated event of the perception component. Bind the event in the begin play event. Add a function to do the line trace and return the hit result. Add two public F vector properties, one for the noise location and another for the scene target location. Both will be blueprint readable. Add two public boolean properties. One will indicate target is seen and the other something is heard. In the active perception updated event, check which perception was triggered and set the properties accordingly. Set up sight and hearing in the perception component in the NPC character blueprint. The infected has limited sight and thus the sight radius can be set lower than the default value. Primary sense used by the infected is hearing, even if they have limited sight. The hearing sense radius can be set higher than the default to reflect this. In the player character blueprint, noise generation needs to be set up. The AI must be able to sense the nearby stationary targets. This was done by creating a logical breathing sound that propagates over a very short range but has no audio. The infected hear about 6 times better than the hunters. In order to differentiate the infected even more, they are more difficult to approach stealthily. This was done by scaling the broadcast radius of the logical movement sounds with the speed of the player. This allows approaching the infected more quickly from further away but requires slow movement at melee range. In order for the noise generation to work, add a all noise emitter component to the player character blueprint. To register with the NPC perception, add an AI perception AI source component to the player character blueprint and register for sight and hearing. The AI for a specific type of character is implemented as a set of skills that invoke a hierarchy of behaviors. Step 3. In the character type C++ header file, add a new enum for skill. Skills used by each type of infected are sorted by priority. Priorities specify which skills should be allowed to interrupt each other. The goal is to share as much of the AI between the infected characters as possible so that new character types can be easily added. Skills available in The Last of Us include Chase, On Fire, Search, Sleep, and Wander. Add a new public property to the character type which is an array of skills. In the controller class of the NPC, add a public property of the same type as the NPC character which is blueprint readable. Implement the onPossess event and set the new property to the possessed form. Add a public property that will hold the current use skill. Set it blueprint readable and visible instance only. Add a set current skill function that is blueprint callable. In the function, set the current skill property to the new value if the character type of the NPC contains the desired skill. Add a function called update movement speed and is blueprint callable. This function will set the NPC movement speed based on the speed property in the character type of the NPC. Implementation. Create data asset files of type character type for each infected required in your game. In this example, I will create two files, one for runner and another for clicker, to test and debug the perception. Set up the characteristics and skills for each character. Add an NPC character in the level and test and debug using the different files. Next, create a state tree. Add nodes for each behavior required. Add a condition to each behavior node to match the relevant skill. Set up the transition for each node. Create a state tree evaluator. Add the evaluator to the state tree. The logic to select the appropriate skill for the infected character is implemented in an evaluator. Implement the selection logic and set the current skill on the NPC controller to the selected skill. Create state tree tasks for each behavior. In this example, I will start with implementing chase and search and end with sleep. Once done, add the tasks to each behavior node in the state tree. Add the state tree to the NPC controller. Execute the state tree start logic function in Begin Play. Now you know how to spread the infection in your own game. Do you find this helpful? Share your thoughts in the comments. Thank you for watching. See you in the next one.